Ladies and gentlemen,
That's it.
Super Frank Copsidas.
Thank you very much, Jim. Thank you and good morning. I've had a varied career. So the story behind this, I was in radio broadcasting from 92 to '04 in the US and owned and operated 14 stations and got bought out with consolidation. About 2015, I got involved in LPTV. So I keep getting asked, what is LPTV? In the US, we have two basic standards of TV: full power, low power. Low power is 15 kW and less, and high power is above 15 kW in UHF. VHF, it's 3 kW. Okay, but we're like the only country that does this. There are 5,500 low power licenses in the US. There's 1,700 full power. So there are a lot of low power stations. And this Tuesday was a landmark for the LPTV Broadcasters Association because we've been pushing and pushing for this. But as of this past Tuesday, we could file for a channel change, which is the first time in over a decade we were able to do that. So I landed up changing two of my channels way for the better, and we're excited about that. Also, the FCC handed us 82 pages of rule changes. And so comments to the comments are due Monday. So we're heavily into that. Our biggest thing, basically, it's more ways for the FCC to fine us. That's what it comes down to. More paperwork, more everything. We don't think most of that will go through, but who knows? The other thing we are pushing for in there, so we're limited to 15 kW right now, and it's based on 30 years ago, people were sitting around a table and saying, low power. How much power should they be able to put out? 1 watt, 1 kW? Somehow they decided on 15. They had no clue what kind of coverage there would be. So in the rules is 15 kW. Well, move ahead 30 years, we'd advance. There's beam tilting. There are all kinds of technologies now where we say, why can't we take our signal and as long as we stay in our contour, because theoretically that's what the FCC cares about, why can't we put down as much power as we can so if somebody buys the $20 cheap TV antenna, they can receive it because we have enough power to get in their house. So that's what we're pushing for as the next step. It's not going to be part of this NPRM, but a future one. We're also involved with Congress. Nothing to be said there. Unless you have a check. Then they listen. But otherwise, and we don't have checks to hand out, so we talk, hopefully. So 3 years ago, 5 years ago, I got interested in, when I was on the Rhoda Schwartz site, I saw 5G broadcasting. And I'm like, So I looked at it and I called them up and I spoke to them and landed up speaking to one of the developers. And they said, not happening in the US anytime soon, but maybe in other parts of the world. I said, so why do you have it on the US website? And they said, for the future. So I said, okay. So 3 years ago, I landed up getting a little more interested in it as we were trying out ATSC 3.0 on my station in Boston. And we spent 17 months trying to get it up and working. So by up and working, what do I mean? I mean video and data, right? Two very separate deliveries, the way it's set up. So we could get video working most of the time, or data. We could not get both of them going. So after 17 months and spending $60,000 for engineers to come in and oh no, I'm the guy who could figure it out. Great, come on. Nope, didn't happen. So after 17 months, we said that's it, and we went back to 1.0, ATSC 1.0. In the meantime, I'm looking at 5G broadcasting, and I spoke to a former chair of the FCC. This is 3 years ago. And I said, how do we make this happen? He said, I have two things to tell you. You can climb Mount Everest 2 times, and that'll be easier. To summarize, number 2, it's not happening in your lifetime. Well, move ahead 2 years, and on last September 13th, WWOO in Boston, one of our low-power stations, actually launched the first experimentally licensed 5G broadcast station, first 24/7 5G broadcast station in the world. The second thing we did October 13th is put out software that could be downloaded onto an SDR that most ham radio operators would have to actually receive our channel. So it was the first anything for the public to actually receive 5G broadcasting. So one of the big questions is, how far have we come in 5G broadcasting? And it's not, we've come light years in a year and a half. So it really started about a year and a half ago, even though Rhodey's been on it for quite a while, about a year and a half ago. As we sit here today, there isn't even a version modulation software, version 1.0 out. Everything is still beta. Next month, IBC 1.0 will be out. But this is the first time. So a lot is developing, and I'll get into that. So what is 5G broadcast? It's really simple. We spent over a year and a half just trying to get people to understand this. Direct into your smartphone. Direct from a free over-the-air traditional broadcast signal going straight into the smartphone. So what does that mean? Oh, I need cell service. No. Oh, I need a SIM card. No. It's just like satellite in this iPhone receives satellite through on the chip. It's opened up. It's a separate platform, the satellite reception. Cell, separate platform. The next one, Wi-Fi, separate platform. Bluetooth, separate platform. We are a separate platform in there. So, for example, the smartphones we have right now that can receive 5G broadcast can only receive 5G broadcast. They're not set up at this point to interact with cell. But as of 2 weeks ago at the Paris Olympics, using the Xiaomi phones, they have a return path through Wi-Fi. So again, we're brand new. It's baby steps. Every couple weeks, something new is coming up. Has Qualcomm figured out how to make it work with the cell service? Our theory is yes, but they're waiting to get paid by somebody. So it'll be out there. We see it rolling out sometime next year. The other big misconception out there is, what is 5G? That is probably one of the best and worst terms, because there's the marketing 5G and there's the technical 5G. Two completely separate worlds, right? So for the last couple of years, we have 5G service on our cell phones. Well, it's really 4G LTE, right? Wearing a cape that the marketing department put on that says 5G. True 5G, at least in the States, you have true 5G service when on your phone the little 5G comes up and it says NR, which is new radio. That is true 5G, next generation. But most 5G, as we know it today, is 4G LTE, and that is what 5G broadcast is in. So 5G is a term I say it's like Baskin-Robbins ice cream. There's 31 flavors. All of them taste different. There's so many different 5Gs to get confused. If 5G private cell network is different than 5G cell, is different than 5G broadcast. They're all different. So don't get confused or sucked in to think 5G is just cell. It's many, many, many different levels. So, I went one too far, a couple too far, I think. How do I go backwards? Here's how I go backwards, yep. So, a 5G broadcast overview. Off of a tower, where can we go? We could go direct to mobile. What we showed in Boston last year, we can put out emergency alerts in under half a second to everyone. Why? Because we're broadcast, one to many. So in New York, when we had the earthquake a couple months ago, it took between 30 seconds and 3 hours for the cell phone carriers to notify everybody there was an earthquake. Why? Because it's all one-to-one. They have to send out a signal to every single subscriber, whereas we're sending out all at once, it's out, period. So once they're in the phones, then you get the emergency alert immediately. It's one-to-many. One of our major focuses in 5G broadcasting are first responders, which I will get into a little further. And then there's video, audio, and data. Again, data being very different than video and audio. And one of the probably the area of most interest around the world is still long-distance learning, especially when you get into third world countries. So there's the ATSC standard. So LPTV stations in the US, I discussed that already. Broadcast stations up to 15 kW. You can do in the US ATSC 1.0, 3.0. So if you go 3.0 as a full power, you have to simulcast a signal in 1.0 in your same contour area. As a low power station, you can get a waiver, so you only have to go 3.0. Right now, you cannot get a 5G broadcast license, but they will give 5G experimental as long as you have a plan well laid out what you're doing with it. VHF, UHF, so in the UHF spectrum, we're at 470 to 608 megahertz right now. After the auction that happened 6-7 years ago, T-Mobile got the most of the 600 megahertz frequencies. And here's where we get a little crazy. Frequency range for 5G broadcast is actually called band 108. And I'm going to do that on the other side. 5,300 licensed LPTV stations in the US. Then you have global. And this is where it gets interesting. So it's a global standard, 5G broadcast. The same way everything in 5G is a global standard. It comes from the 3GPP standards, which is the worldwide association that comes up with all these standards, and it's one standard for the world. And that's why your cell phone works in Canada, in New York, in China or India. There's only one platform, basically, for 5G cell. So it's the same thing for 5G broadcast. Where it gets really interesting in emergency alerts, currently on cell phone alerts. So one of our business manager, her daughter was in Israel, and there were bombs going off, and she got no alerts on her phone. The reason for that is the cell phone carrier in Israel uses a different standard for giving out those alerts. Now, her US cell worked there, but it didn't work for emergency alerts. In 5G broadcasts, we're going to be on one platform, so no matter where you are in the world, you'll get emergency alerts. So we see that as a big advantage on a worldwide basis. Depending on the country you're in, it's 6, 8, 10 megahertz broadcast spectrum. You can use the existing broadcast chain by upgrading the modular exciter. I'm going to put a note on that. If you have a transmitter that's 2017, 18 or newer, because it has to have OFDM because it takes higher power. Otherwise, all you really need to do, depending on the exciter, you might not even have to change that, but it's the modulation software. Frequencies, band 107 and 108. So 107 is used all over Europe. That's basically what T-Mobile bought here in the reverse auction. So band 107, also known as R71 in the cell world, is in phones everywhere. So in Europe, it's very easy for us to provision a smartphone to receive 5G broadcast. Why? Because it receives these frequencies, the antennas are in there. The only thing that's not opened up is 5G broadcast. To do that, you take some software, magic software, go into the base chip, and then open it up. We've got that software in our office. We do it all the time. Not that big of a deal. To open up the US frequencies, there's a little more work to be done. So we have to open up the filter on the phone, in the chip. That's not so bad. But the antennas in there need some tweaking to get that down to that 470, 500 range. So basically, in our Qualcomm QRDs, which are the demo phones, they literally open them up and resoldered antennas. So right now, they're within the mobile world. There's 3 manufacturers working on actually getting it ready for the US band. So band 108 is the entire spectrum of broadcasting around the world, which is 470 to 698. In Europe, they use pretty much 612 to 652, and these are all broad strokes because some countries are a little different. In the US, we use 470 to 608, so we're really subsets of that whole band 108. And 108 is the worldwide standard as passed in 3GPP last October. So about 5G broadcasts, global standards I just talked about can be received directly by smartphones, by CPEs, customer premise equipment, which is getting more and more and more interesting too. It excites me, things that excite me. Any device with 5G broadcast-enabled modem. We utilize eMBMS, and in the future, FEMBMS, which is part of the true 5G standards. And DTS, so most people know them by SFNs or other names. SFN, single frequency network, basically a repeater within your area. In the US, the FCC said we only recognize DTS, digital transmission systems. So everything, whatever flavor it is now a DTS in the States. So we do direct transmission into a smartphone, multi-platform delivery, emergency alert broadcast under half a second, life-saving solutions for first responders. We can use the latest audio and video compressions for streaming. So in Boston, which is a year ago, we did a 720p, actually, we did a 4K signal using 1.2 megabits per second. And for the 720 phone one, we're down to 600 kilobytes per second, about to go to 300. And the picture is stable and brilliant. And we utilize existing broadcast infrastructure. So delivering of streaming content directly to a phone, sure, we can be just like television stations and put down multiple programming streams the same way you do on television. We're one-to-many. We're cost-effective conversion for existing broadcast stations. We're a backup for MNOs when they go down in emergencies. So this is politically sensitive. Cell phone coverage doesn't fail, it goes down. So if it goes down, what happens? When does it go down? Typically in an emergency or a huge crowd when you need that kind of coverage. We can offload MNO video feeds without feed interruption, so there's seamless switching that can go back and forth, that can analyze, oh, only 2 people in the stadium are watching the game right now, so we'll do that over cell. But now 10,000 people are watching the game on the phone. We'll deliver that over 5G broadcast. That switching is like instantaneous. Last year it was about 3 seconds to switch. Now it's no latency whatsoever. Broadcast tower benefits, most of them are in secured locations and also have industrial backup generators. So when cell service does go down, pretty much broadcasting continues. So direct to mobile, current state, reception of basics. 5G broadcast is a distinctively separate receiving platform on a smartphone, as I said in the beginning, similar to satellite reception. It's not dependent on 5G cell. There's no SIM card required or anything. Now, in DC last year, we showed a CPE receiving 5G broadcast. That CPE has Wi-Fi, and we connected that to a tablet. And everybody said, so you need Wi-Fi to do it. No, we don't. It goes to the CPE via 5G broadcast, and the CPE then theoretically goes through your house, your office, whatever, distributing on Wi-Fi locally. Do we have a return path? As I said, the big breakthrough was just Wi-Fi during the Olympics. So for the Olympics, TDF, France's broadcaster, gave out 250 Xiaomi phones and had 4 broadcast towers, and it went really well. Yeah, it's kind of anticlimactic to a certain extent, because here are the phones. You can watch the Olympics. Okay, I'm getting it. And it's done. So it's a really simple, nice, clean. You do need an app on your phone, right, to open it up. It doesn't just appear, although we're working on that for emergency alerts. Direct to mobile, future state. So we have 5G broadcast going in, 5G cell, 5G satellite, 5G Wi-Fi, 5G Bluetooth. And on the other side going out, we have a lot of return paths. But one of our big advantages is we're broadcasting one-to-many. We don't care if one person receives the signal or 1 billion people. It's the signal, period. So it's our delivery ability. ATSC and others current chain, you have the usual CPU server, decoder into the encoder modulator, into the exciter, into the amps, into your antenna. All reusable, and it goes into TV. For 5G broadcast conversion, what you're basically doing is changing out the 5G broadcast modulator. So we've been working on exciters for the last year, because most exciters either have ATSC 1, 3, ISDVT, DVB, and DVBI, but they don't have 5G broadcast in there. Most exciters, we found out, are designed to either do one of those, period. So you can turn one on, turn the other off through licensing. However, we found one manufacturer in particular who made an exciter with all those platforms in it, but you could turn them off, turn all of them off, and feed a modulation scheme from an external source. So that's what we're doing. Actually, as we speak, we are installing a new transmitter and exciter in Danbury, Connecticut for POC2, which I'm going to talk about, but it has one of those exciters. So we use an outboard little computer that has the modulation software on it, and we're feeding that modulation software into that exciter. So if you bought that exciter and that transmitter 5 years ago, all you need is the modulation software to change it. That's it. How long does it take to install? We have a portable unit, 100 watt in a flight case that we do tests with, and we just got that. Monday we did a test. First time using it, it took us an hour and 15 minutes to get it totally functional. So it's pretty easy. So you use your current antenna, and then it goes into a smartphone. You have programming, emergency alerts, first responder, and CPE data offload. Now we get into the fun stuff of XGN Red, emergency alerts and first responders. So we talked about the emergency alerts. Simple, don't need to talk about it any further. But they're also not only emergency alerts to the public, but emergency alerts to first responders on the scene. There's also emergency alerts that are more local. So, for example, there was last year, in a stadium, had a tornado coming in just as everybody was arriving. They had no way of letting people know, don't come in, stay in your car, stay away. So with this, we're working on localized, actually that's what we were testing on Monday. With the 100 watt transmitter at a stadium, we got about a mile of coverage. We lost some coverage in the elevators and behind one parking lot. But that was using a broadband two-way radio antenna. So we figure once everything's honed in a little more, we're going to be in good shape. We're going to, next time we're there, which is end of September, we're going to bring a 400 watt transmitter and just start at 100 and see how far up we need to go to get into those elevators and into that parking lot. So you have two kinds of emergency alerts, one for the public, one for the first responders. The other thing about first responders, they don't want to carry any new equipment. So you say, well, you could put a chip in this or a chip in that. They don't want to hear it. No new equipment. So it all goes into an existing smartphone. So I pause alerts in under half a second. Now, this is another part that gets really interesting. So currently, let's take the stadium example again. You call 911 from sitting in the stadium. This fascinated me too. So before it even rings in the dispatch center, which is in the stadium, they have one there, up pops all your information, your name, your address, how old you are, any medical conditions. So that pops up before the phone even rings to the dispatcher. So the dispatcher then says, 911, what's your emergency? By the time she says that, he says that, cameras in the stadium have focused in to where you're sitting, the section. They can't get down to the seat yet, but they can get the section. So here the dispatcher's looking at what's going on in video and everything else going on. The problem is they can't get that video out to the first responder. So think of a dispatch center as a TV control room. So that's what we're working on right now is, well, if you have something else going on, God forbid, like an active shooter, they have to say, he's 6 foot tall, he's wearing green, he's going down staircase 2. This way, they have feeds coming from closed circuit cameras, from drones, from everything. The 911 dispatch center is a TV control room like for the Olympics. And which feed do you want to get out to the first responders? So that is what we're doing. Spectra Rep has that app out. It's a great version 1 of the app, which turns it into that. However, it needs to be a lot smarter. And AI, we're working with AI to make that a smarter app. So really, you could take that to the local level. A fire truck gets to a fire, the fireman's climbing the ladder, drones inside. They have 5 drones there, whatever, and some closed circuit cameras. The fire truck could then, using 5G broadcast, put it right out to the fireman on the ladder so he could see what he's going into. So it's actually bringing video into the field. It's bringing television into the field. So that is all essential encrypted video delivered directly to first responders' smartphones in an emergency situation or large gatherings, even if cell service is not working. And it is the first thing that goes down is cell service. And so it goes down, right, doesn't fail. Cell service goes down. And that's when all the communication, FirstNet, all those things, they're not working. So we continue to work along with two-way radios. So we complement each other really well. X-Tech, then we have XGN Tech, which is another side of our company, and we're developing software and hardware for current and future development of 5G broadcast, from the 5G core to the modulator to the apps. So we don't want to get too complicated today, but really up in the cloud is the 5G core and the O-RAN communications. So up there is where you communicate in the cloud with everybody in the world. And it comes into through O-RAN into the core, which is core heavy, which then gets delivered down to the station and is put out on the air. What happens if the connection between the cloud and the station go down? Well, there's basically a core light that would stay at the station, which would keep it going. Also, we're looking at multiple delivery platforms, so as well as having fiber, you could also have satellite or whatever and cell. And whatever is working could deliver through. So we're working, and that's the beauty. We're working, that excites me about CPEs, the customer premises equipment, is the idea of convergence. So right now you have your cable box at home for internet. Well, that cable box soon will have in the next couple of years, and we've actually got 2 developmental CPEs in our hands, where in that box, you not only take in coax, but you take in satellite, you take in 5G broadcast, you take in Wi-Fi. It has everything in one. So as a consumer, you do the same thing, plug in. You just don't know how it's being delivered. Do you care? No, you just want it delivered. So that's the future of CPEs and how they interact. But we're probably 2-3 years off from that really, really working. Current advancements. So as I said, September 13th, 2023, we went on the air in Boston. September 14th, we demoed it at IBC with broadcasting and alerts. October, we put out the first SDR event for the software. November, we did POC 1, Proof of Concept 1, for the FCC. And the FCC said, we want you to do 2 things and only 2 things. We want you to put down a video stream that we can see to a smartphone and to a CPE. We did it. And the CPE was connected to a 4K TV. So we did that. And the second thing was an emergency alert and under like immediate. We demoed both of those. That's all they wanted to see. We went to DC on November 2nd. We presented it. Everybody was happy. So it's been kind of quiet this year. April 14th, we were at NAB. We had a booth. We showed 5G broadcast going to smartphones there. We also launched the 5G Broadcast Collective at NAB, which is basically an association of 5G broadcasters and equipment manufacturers. And right now, the other thing that happened is basically all the major equipment manufacturers, transmitters, said they will have some kind of 5G broadcast solution out. So currently, there are only two modulation schemes out there. One is made by Bitstem, which is what basically everyone is using, and the other, which will have the 1.0 version at IBC. The other is Rode Schwartz. That is it right now. We understand there are two others in the process of being developed, but they will not be coming out for IBC, or so we're told. So it's coming along. It's been kind of quiet this year because so much has been in development. Every couple weeks is like a miracle. So as I said before, there are things like data is separate. Right now in 5G broadcast, up until a week and a half ago, all we could do is get video, audio, and metadata down that pipe. We could not get straight data down the pipe. It just wasn't going. A week and a half ago, my guys figured out how to do it, and we now can go into road signs. So that's our use case right now for emergency alerts, basically. Because if you're in an airport, Wi-Fi goes down, cell service goes down. They need to change all those signs immediately to show you how to exit or don't enter, whatever it is. We can do that immediately through 5G broadcast. So we're working with certain companies that make the routers for those signs to put 5G broadcast in. What does that mean? You have to have the right chip. The right chip for data is different than the right chip for smartphones, but all of this actually is very much being developed literally as we speak. So chip manufacturers, whether it's Qualcomm, MediaTek, Quectel, or any of the others, they're on it now. This is real, and they're moving forward with it. Worldwide deployment at a glance, this is really hard to read, but Germany, Belgium, France is actually committed to go all 5G broadcast by 2032. The US, we're doing things here. Spain is very big into it. Brazil had their conference this past week where they announced they're going to TV 3.0, which is partially ATSC 3.0, but at the same time they were showing the Minister of Communications, along with Rode Schwartz, were showing 5G broadcast for the future. So they do want to get into the mobile platform. They are looking at 5G broadcast. You have Croatia, Greece, Austria is big in this. ORS in Austria, which is pretty much a quasi-state-owned company. So as opposed to the US, I think as opposed to Canada, the frequencies are actually owned by the tower company. So the tower company owns the transmission site, the transmitter, the tower, and the license. And then they, in turn, license it out to programmers. And most of Europe works that way as well. 2024 realities, our current status. 5G broadcast is still in early stage of development. So when we're told, oh, but you can't do this, or you can't do that, or you're not in phones right now, all very true. We're developing. We're a year and a half old. We're getting there really fast. By middle of next year, we're going to be out in some commercial forms already. Consumer, probably not, but business, yes. We'll also see some devices starting to hit the market. First, specialized devices for first responders, but very soon thereafter, there'll be models out that will have the chip opened up to receive 5G broadcast. Content strategies. Well, harsh reality is linear TV is dying. So where does linear TV excel? Well, there are a couple areas. Live sports, for sure. There's a demand. Breaking news, there's a demand. There's also a demand in specialized programming. So if you take ethnic programming, you'll probably have an audience that will watch on their smartphone. Will today's millennial or Gen Z watch Gilligan's Island on their smartphone? No. So we have to look at what are the uses going through. And of course, regulations. So in the US, the FCC hasn't agreed to license these. They give us experimental licenses, but that's it right now. So US proof of concept, phase 2, quarter 4, 2024, which is what we're getting ready for right now. After our successful proof of concept in Boston, our next set, where there are 4 stations being put on the air. We're going to relight WWOO in Boston, but with a new T-Redis exciter and transmitter. We're going to do an SFN in Boston. So it's the first time an SFN will be deployed. So we have to make sure all that works with the GPS and all that wonderful stuff. The third station is WTXX in Hartford. And the fourth station is the one I talked about this morning, getting the new T-Redis equipment installed today, which is Danbury, Connecticut. So Danbury, Connecticut and Hartford overlap. They're on different frequencies, but contours overlap. So we're working on, does your phone or the CPE continue to pick up the signal even though you've left a contour and you're in a new contour? How do you pick that up? How do you hand off? Do we expect that to figure that out entirely in POC 2? Maybe, maybe not. Depends which way the wind is blowing. You know, we hope it's going to be okay. So programming will deliver one HD over-the-air programming stream and one radio station. So if we can do a 720p station in 300 kilobits, we can put in 12 radio stations in that 300, I'm told. So a radio station could have an app and deliver straight to a smartphone the same way. Nobody's really talked about that one. Emergency alerts, we've talked about a couple times. First responder POC, delivering those files, the video, to the first responders. First responder POC, yep. The other thing we can do, so over 50%, this freaked me out when I heard it, over 50% of US 911 dispatch centers are still on DOS. So they're so far behind in technology, and evidently the reason for that is the requirements are when they move to a new software, they have to port over all the old calls that were stored. So they have to convert all this data, which often costs more than the software. So a lot of places just can't afford to do it. So there are firehouses, actually in Boston, that have 100-year-old technology. When you pull the alarm, it all is mechanical, all the way back to the firehouse. So there are ways we can intercept that and get that signal right to the firehouse through CPE. CPE can be programmed to do anything, right? From open the door to a voice alarm to whatever they want. Make dinner for them, whatever. Receivers, we'll roll out new prototypes of data receivers, both smartphones and CPEs. CPEs are heavily under development right now because the manufacturers of those see the end result. There are 2 levels of that. One's in SDR and one is chip frequency specific. So both of those are coming out. SDR keeps coming down in price. So a software-defined radio is definitely the better choice because it can do anything. But let's see where it goes as everything develops. Deployment of a DTS, we'll actually make that work. We know we can make that work. We've made it work in the lab. The problem, which I'm sure a lot of you have had firsthand experience with, oh, it works in the lab. Here it is. And you go to the field and it doesn't work. And they say, no, but it works. We had it working in the lab. Yeah, we're in the field. So until we get it in the field, we don't believe anything works. Transmitter equipment, our goal is to have cost-effective transmitter equipment and software. So again, all that, if you have an OFDM-capable transmitter going into your line, your coax, into your antenna, all we have to do is replace the exciter, in most cases, and modulation software. What are we projecting that cost at? The guess right now is about 25 grand, and you're done. Yeah.
How much coverage do you expect? Are you expecting the cell phone to give you the same footprint as you get from like DTV TV receivers who typically have an outside antenna?
Right. Well, it's a really interesting question. So with
these guys talk to the phone company and little hexagons all over them.
yeah, but we're completely different, right? Because we're not using cell in here at all. So as it depends what kind of signal you're putting out. So for emergency alerts, that thing travels. There's such little data going out, it just keeps going. We were getting out of WWOO, we were getting about 28 miles out, and we got it in the car doing 60 miles an hour. We also got it on Amtrak. Within, depending which direction you went, anywhere from 10 to 28 miles out. Now, it's like ATSC 3.0. So once you deploy it in the modulator, okay. This is where it gets dangerous for my technical knowledge. All I know is the numbers. It goes 1 to 22. 1 is your tightest delivery. So it's like a water pipe, right? So if you're at 24, it dribbles out and goes right at your feet, but you have a lot of data delivery. If you want it to go a long distance, you have to squeeze it to shoot out. So somewhere in the middle there, I'm told 14 is the ideal number, but we haven't really played with that much. We had the Rode Schwartz equipment. When we tried to play with that, it didn't quite do what it was supposed to. By the way, in the 6 months we had the Rode equipment, we probably did, a dozen software upgrades as we find out, oh, hold it, this isn't working as it should. They go back, do it, because again, it's actual field tests, not lab tests. So there's a lot, and they were fantastic in taking that feedback. So to answer your question, for example, at the stadium, we don't want to go more than a mile, mile and a half, or for a local fire truck or anything else. We don't want to go too far because then we have interference issues to deal with as well.
Except that if you only have one transmitter site, how do you, just geo-fence the stadium or the fire station?
Sure. So it's the same way an SFM works, right, for interference, all that. You have to, in this case, the stadium doesn't really pick up the main signal that well, so it becomes a balancing act. So this is why LPTV in the States is perfect for this, because it's low power, low tower. The ideal deployment of 5G broadcast is basically cell. deployment. You don't want that big tower in the middle. You want a bunch of little ones.
But you are going to have to buy all the equipment basically regardless of what the final amplifier is, right? Whether it's low power or high power, pretty much everything else is going to be the same expense.
No, because you're going to really low power. Let's talk about 50, 40, 50 watt units. So the cell world has already developed that. They don't call them transmitters, right? They call them radios. And that radio has the exciter, everything built in. The cell world, some of those are very expensive because they can afford it and they can sell it at that. Are there ways to do those at a much lower rate? Yes. And the question is, they do need GPS for timing. Do they need to be connected is a big question being worked on now. Theoretically, if you look at it, they have to be connected. But somebody figured out a way they might not need to be connected. So that would bring down the cost. But where we're at today, the main station, SFNs where we can, and then probably 3 years from now, we'll start deploying the way it should be deployed, ideally deployed. Now, if you have a full power station, 100,000 watts, 1,000 feet, and do 5G broadcasting, sure, it's great. But what happens again when you hit a hill or an obstruction, right? What you see is what you get. So if something's in the way, you're going to have that same issue. Now you have more of an issue for interference. So high power, again, theoretically in the lab, when you run projections, looks great. But practically, it's a real challenge, depending what you're trying to do. If you're only trying to put out linear streams, great, it works. You don't need anything else.
Yeah.
But if you're trying to do first responder and data, it's not the best. I hope that answered.
Oh, yeah.
Okay. So the conversion, as I said, to the modulator, XGN red. I did that one. Where there? Software, hardware development advancements. I did those. How do we go back? U.S. proof of concept and rolling out 5G broadcast through the world. So at IBC on Monday, we're announcing our program, which is POC for free, which is proof of concept for free with an asterisk, not including travel. But if you pay for the travel, we will go anywhere in the world, and we're talking to 2 countries right now that want us to come in and do 5G demos in their boardroom for their regulators, or they are the regulators. So we as a company, along with 5G Broadcast Collective, will go anywhere in the world and do the demo. We're working with countries around the world. We're doing consulting services. XGN is a for-profit company, and we are developing our own IP, our own equipment, our own solutions for first responders. But at the same time, we need this platform out and being used. So that's why we started 5G BC, to really promote the use of 5G broadcasting. 5G Broadcast Collective is a member of ORAN and GSA. We have to make sure everybody knows about this. I had a meeting with the head of Spectrum, the legislative head of Spectrum for one of the big US MNOs. They knew nothing, zero about this. And after an hour of talking, they said, well, you're the evangelist. We need you to talk to other people in our company because we didn't understand this at all. So it's a matter of getting out there. We are a strategic partner with Qualcomm, and we are very much, we're involved in each other's worlds on a daily basis. So one of the things they ask us to do is get the word out. And it's funny, there's Qualcomm talk and there's our talk. They're kind of two different languages. Qualcomm's talk is very, very technical, and when you get to most of the government agencies that regulate the policymakers, they're not that technical. And broadcast side that's looking at this is saying how much, where's the revenue? They're not that technical. That's the side I speak. They're great at speaking the technical side. So when we're working, like we're working with one smartphone company now, and they need some adjustments to the chip to make it work, and Qualcomm is now making those adjustments to the chip to make it work. So we all work together and trying to spread the word, and that's also why I'm here, just so you understand what 5G broadcast is. Our takeaways: 5G broadcast direct to mobile, 5G broadcast worldwide standard under 3GPP, why it works everywhere in the world. 5G broadcast is new and still in development. I have I'll call him a friend at a major broadcasting company in the US that absolutely hates 5G broadcasting. And in the middle of our November 2nd proof of concept demonstration in front of 50 broadcast attorneys, stood up and said, "Why do you lie? It doesn't work." And we're like, here it is, it works. What do you want us to say? So it does work, but the public doesn't have it yet. You're absolutely right. We're still time off, at least mid next year, at least till it starts rolling out to the public. Absolutely true. So you don't exist. Well, we do, but we're in development. We think there's a lot to be had. And especially emergency alerts under half a second. So ATSC 3.0 obviously can do that. The problem is you need a separate receiver to do it. You need a receiver with a 3.0 chip. Will a 3.0 chip ever be in a smartphone other than smartphones that are actually made for ATSC 3.0? Will they be in your normal commercial? According to the three major chip manufacturers, they never use the word never. In this case, never. That's what we're told. 5G broadcast can bring critical solutions to first responders, and 5G broadcast can supplement cell when cell is down. So join the 5G Broadcast Collective and be in the know. So the 5G Broadcast Collective actually is kind of doing memberships, but not really. All you have to do is sign up for the newsletter, which comes out every other week, which updates what's going on. So if you're interested in the world of 5G broadcast, I suggest just signing up for that newsletter. And we put it out every other week. It too is evolving. Right now it's a collection of stories of what's going on around the world, but I think the one this week is going to talk about the Brazilian show, because we had somebody down there.
I have one more question.
You're not
Talked
on.
about,
There
there
you
we go. He finally turned it on. That's Jim. He's mad at me. You talked about like band 108 and 107. In Canada, at least, all that is viewed as revenue for the government as they sell it off. So, are you in there, or are you guys broadcasting in the television allocated spectrum?
Television
Okay.
allocated. So depending on the country, some countries use this part of 108, some have that part. That's why it changes depending where you are in the world. Is it 6 megahertz, 8 megahertz, 10 megahertz of bandwidth? Country dependent.
Thank you. Is there a relationship between your organization and the 5G MAG group?
Yeah, we're actually somewhere in here, and I think I passed it somewhere. Maybe we took out the slide? I hope not. Here it is. So we are members of 3GPP, Etsy, 5G Mag, IEEE, and LPTV Broadcasters and 5G Collective, obviously, is ours. But we're members of all those. We're heavily involved. And my staff gets up at 4 in the morning for the 10 a.m. 5G Mag calls.
Okay, thank you.
You're welcome. Yeah. And we also, so 3GPP, we're into that as well. So you have to join through an organization, so we join through Etsy, which actually has broadcast as part of it. Yes?
On slide 7, 3 up from there, you were talking about having to modify salt filters to open it up. I can't remember the frequency you mentioned, but it was pretty significant. Yes, no? I don't hear anything. Okay, anyway, and I'm curious, you know, it sounded like almost doubling the operating bandwidth. That's going to have an impact on the noise floor. Is that going to affect your LTE signals?
No. What has to be done, we're told, is it's minor work. It's just painstakingly delicate work, much easier done in manufacturing than retrofitting. The software can be, is backwards compatible all the way, but as Qualcomm says, we're not in the business of giving updates. We're in the business of selling chips. So you'll see it in new chips. So for the phones, it's the soldering, which is much easier to do in production, versus the chip is really opening up the filter, which is software. So when we go in to open up a phone, we have the Qualcomm software that'll go to the baseband chip, and we can open up the frequencies. And they're not supposed to scan, but they do. Yes?
Yeah, in that particular slide, global 5G broadcast standard, is it a 5G broadcast standard? Who owns the standard? 5G?
3GPP, that organization that has hundreds of members, they meet twice a year, and they go through all the standards, and they vote on the standards, and it is the worldwide standard.
And how come that they said that band 108, which belong to the UHF TV channels, is part of the 5G broadcast standard? This is long time ago. From the very beginning, it has been defined. And how come it became a band 108 and belongs to 5G broadcast standard?
What they work,
It is grandfathered, you know, the UHF channels.
Right.
This is already grandfathered up to 860 megahertz.
well, we're just a new protocol for broadcasting,
Yeah.
right? So you don't have to do it. Band 108 is where it lives if you decide to do it. So nobody's making you, me as a broadcaster in the US, nobody's making me do it. If my business model says I want to go 5G broadcast, theoretically I can do that, or ATSC 3.0, or stay in 1.0.
No, but my question is, how come that 3GPP said that band 108 is 470 to 698 megahertz, whereas that is standard UHF channel? How
So-
come how come that they said this band now belong to band 108, whereas it is a standard for the UHF channel?
Right, so it is the standard for UHF.
Yes.
You have to actually go one level or a different place
Yeah.
for that, which is at the big conference last year or this year, Dubai, where they all the countries get together and decide spectrum allocation. Those are the guys who actually came up with it. The what? World Radio, yeah. At that, they decide which frequencies are for broadcast. 5G broadcast then goes within the broadcast frequencies.
Okay, sir. I don't like to hijack the whole questioning
I'm
period.
happy to talk to you after this.
Yes, thank you.
Your comment about the ATSC 3 chips in phones and the never comment from the manufacturers is reminiscent of the issue I think that existed with ATSC MH, which was that Samsung, LG displayed prototype phones at NAB that were capable of reception. And when I was at CBC, we actually did a test with those. It seems to me the message from the wireless carriers to the manufacturers was, we don't want to market any product you make that is going to eat our lunch. So do you not have a serious issue that, notwithstanding the fact that you can develop the technology, Qualcomm develops chips, but how do you get Apple, Samsung, and the others to actually put that capability in the phone?
Right, so that is definitely a challenge, and why we have ongoing conversations with the MNOs on this. We do it, Qualcomm does it, all the manufacturers are doing it. With ATSC 3.0, the difference is ATSC 3.0 was never going to be on the chip, the one chip, that satellite 5G broadcast, the 3GPP chip, let's call it. It was a separate chip that had to be put in the phone, which means more power consumption and more real estate, too, to put it in there. So I think the problem or the challenge with 3.0, it's a separate platform, separate chip. We're actually on the chip that cell is on or satellite is on. So as this goes down the line, for MNOs are starting to think, actually we're pretty good for their offloading and for when they go down. Funny enough, there's been more support than pushback. But I say that and knock on wood, right?
All
But
right.
it is definitely something we're into.
Okay. We want to thank Frank very much
Thank
for
you.
coming all the
Thank
way
you for
here.
having me. I leave that to your imagination. That's it.
Frank, I have something for you from the CCBE. We want to thank you for coming.
thank
We
you.
appreciate it very
Thank
much.
you. Appreciate it. Am I holding this the right way? Oop. Thanks. Thank you. If you have any questions.